Hi everyone. This lesson I'm going to demonstrate how to do some problem solving and will be assisted by my Casio graphing calculator. So here's a lovely question. We've got the branch of a eucalyptus tree is modelled by a cubic function. The coordinates of several points on the branch are given, and the function has the rule of the function has the form of a cubic equation. Now that's fair enough. If there are 4 points, then we could get a perfect fit with a third degree polynomial. Now, it seems like we've got an x and a y axis already set up with the origin down here, and we can see there's this red line here that's following along the branch. It's a little bit hard to see against the background color, but it'll do. Where would these points belong? Well, let's mark them in. 0, 15.8, that one would be there. Then we've got 10, 15, and 20. So noticing that 20 is all the way over there, that would be the coordinate 20, 15. 10 would be roughly in the middle, so that's about there. That's the one with coordinate 10, 14.5. And 15 would be about halfway between 10 and 20, of course. And that one has a y coordinate 15.6. And I should note that original one was 0, 15.8. Now, how do we go about solving this thing? Well, the first thing I'm going to do is write down my cubic equation. So the standard form, ax cubed plus bx squared plus cx plus d. Now, if we know the values of a, b, c, and d, then we have our unique cubic equation that we're going to use. But I don't have a, b, and c, and d. What I do have is values of x and y, and I have 4 different pairs of those values. So I could substitute the value of 0 into the right-hand side and the value 15.8 into the left-hand side. And that would be my first data point. So 15.8 is the y value. Now, this would be a multiplied by 0. That's, of course, nothing. And it would be b multiplied by 0. And also c multiplied by 0. And then plus d. Now, of course, that simplifies very nicely because all of those pieces really aren't there. And we've just got little old letter d equals 15.8. So that one really was great. That's not even one of our equations. I might rename that. I might just go, let's call that equation 0, if you like. That's confusing. I don't like. We're just going to make that statement. And now we're going to set up 3 equations in 3 different unknowns. So in my first attempt here, I'll put 14.5 for the y value, and I'll be using 10 for the x value. So I'm thinking 10 cubed times a. That's 1000a. Then I have 10 squared times b, 100b. And I have 10 times c, that's 10c. Now it still has plus d, which is 15.8. Now, I don't like the fact that there's a constant on the right and a constant on the left. Usually we group all the constants together. So I'm going to move the 15.8. I'm going to subtract 15.8 from both sides. If I subtract 15.8 from the right-hand side, it disappears. And to save a bit of space, if I subtract 15.8 from 14.5, I should end up with negative 1.3. Now that's it's a simplified version of that equation. Let's use the next data point for equation 2. So we'll have 15.6. We have 15 now as the x coordinate. So we need 15 cubed. Of course, you could use your calculator. That's 3,375a. And then we have 15 squared, which is 225b. Then we have 15 times C, and then we have plus 15.8, which was the value of D that we had from our original data point. Now again, I'll subtract that. Subtracting 15.8 from there, and this time I'll end up with negative 0.2. My third equation. The y value is 15, the x value is 20. So I might jump straight to subtracting the 15.8 this time. So I would have had a 15 and I've subtracted the value of D. Now a y value of 20 cubed is 8,000A. 20 squared is 400 times B plus 20C. Now there's my three equations in three unknowns. And they're not particularly nice looking equations. I wouldn't want to be solving them on pen and paper. So I'll use my calculator to do these. Now the way we do this is we use this equation app here. So let's go down to the equation app, and we have a choice here of F1 simultaneous equations. I have three unknowns. The letters A, B, and C are the unknowns. Now the way the equations are set up here, the calculator uses the capitals X, Y, and Z as the unknowns, and the little numbers A, B, and C are the coefficients. So the numbers, the big X, Y, and Z correspond to the unknowns. So I need to put in the numbers here. So I'll have 1,000, then 100, the coefficients, then 10, and then the constant for this one was negative 1.3. And we keep going, 3, 3, 7, 5, 2, 2, 5, 15, and the coefficient, the constant for that one was negative 0.2. And our last equation had 8,000, 400, then 20, and finally negative 0.8. Once we have the equations entered, we press the solve button, F1, and we get the values of the unknowns. The calculator uses X, Y, Z for the unknowns. Our unknowns are A, B, and C. Now, the numbers here may or may not display with very many digits, but we can see them here if we use the arrow key to move downwards. And those are the unknown values we needed. So I will write down the equation, or I'll write down my solution using the CG50 equation app. I had A equaled, and it was negative 2.87. I've rounded that slightly by 10 to the power negative 3. B, what did B equal? B equaled 0.095, and C equaled negative 0.793. And that, of course, is my function, negative 2.87 by 10 to the negative 3x cubed plus 0.095x squared. There's no way I would have done this one on pen and paper. 793x. And don't forget, D from our standard was 15.8. So plus 15.8. That's the cubic function, which is going to model the picture on my graph. It should go along here like this. Now, that's part A, find the rule. Part B, find the coordinates of the point on the branch that is closest to the ground and furthest from the ground. So closest and furthest. Again, I'll use my calculator to do this one, and I will enter that function in the graphing app on my calculator. So we'll go back to the menu, and we'll go across to the graph. And bear with me for a moment while I pause and enter this equation. Okay, so here we are, we're back. I finished entering the equation, and I'm just going to hit F6 here to draw that. Now, bit of a disappointment when I see there, can't see the equation, what's going on? Well, let's go back and have a look here, first of all, at the picture that we were trying to emulate. We had an x-axis that went from 0 to 20, and then we had these points here which were y coordinates around 15. So it would be a good idea perhaps to make the maximum on our window about 20 for the y as well and about 20 for the x. So that's what I need to do. I need to set the view window. The view window is F3. I'll put 0 to 20 and let's go up in steps of 5. Don't worry about the value of the dots. That just is how large a pixel is. It'll automatically figure that out for you. The Y minimum will also go from 0 to 20. Might as well go up in steps of 5 for that one as well. Press exit, redraw, and there's the picture on the calculator that looks pretty close to the diagram we were trying to follow. Now to find the point on the branch here, which is closest to the ground, I go gsolve minimum. And there is the point when x is 5.6 meters, the branch is 13.8 meters above the ground. If I do gsolve maximum, when x is 16.5 meters from the tree, the branch is 15.7 meters above the ground. And that's how we use our calculator to create the model. We did simultaneous equations on the calculator, and then we used the graph and we checked the window size, and now we've done some minimums and maximums to answer some questions. The calculator on a TechActive paper really needs to be utilized like this to full advantage. Thanks for watching.